Randomized crossover trials represent a gold standard in nutrition science because they provide a uniquely powerful way to isolate the effects of specific foods on metabolic health, gut microbiota, and systemic outcomes. Unlike traditional parallel arm studies, where groups of participants receive different interventions simultaneously, crossover designs allow each participant to serve as their own control, receiving multiple interventions in a randomized sequence with washout periods in between. This approach dramatically reduces the influence of interindividual variability, differences in genetics, baseline microbiome composition, insulin sensitivity, and lifestyle factors, making it possible to detect subtle but meaningful effects of whole foods that might be obscured in conventional studies. The growing body of research on pistachios offers an excellent illustration of how crossover trials can reveal the full potential of nutrient-dense, plant-based foods in ways that are both scientifically rigorous and clinically relevant. In a pistachio-focused, randomized crossover trial, participants might alternate between periods of pistachio consumption and control conditions, such as isocaloric refined snacks or habitual diets. Because each individual experiences both interventions, researchers can directly compare outcomes such as blood glucose, insulin response, lipid profiles, inflammatory markers, and gut microbial composition within the same person. This design effectively controls for confounding variables like age, baseline diet quality, physical activity, and microbiome variability, which are often significant sources of noise in nutrition studies. As a result, the observed effects of pistachios, such as increased abundance of SCFA-producing bacteria, improved fasting glucose, enhanced satiety, and reduced postprandial insulin spikes, can be more confidently attributed to the food itself rather than extraneous factors. One of the most striking advantages of crossover trials is their sensitivity to functional, microbiome-driven outcomes. In pistachio studies, researchers have demonstrated that even modest daily servings can significantly enrich beneficial gut bacteria such as Roseburia, Faecalibacterium prosnitzii, and Bifidobacterium, while promoting short-chain fatty acid, SCFA, production. These microbial shifts are often subtle and individualized, meaning they could be missed in parallel arm studies where group averages dilute individual responses. By allowing each participant to serve as their own baseline, crossover trials capture these nuanced microbial and metabolic changes, offering a clear window into how a whole food like pistachios interacts with host physiology and the gut ecosystem. Crossover designs also excel at revealing time-dependent effects of diet. For instance, pistachio interventions can be examined in relation to both acute postprandial responses and longer-term adaptations in microbial composition and metabolite production. Researchers can assess overnight glucose stability, SCFA production during fasting periods, and changes in inflammatory signaling over time, all within the same participants. This temporal resolution is critical for understanding the dynamic interplay between diet, microbiota, and host metabolism, and it provides insights into optimal meal timing, portion sizes, and habitual integration of whole foods for sustained health benefits. Another notable strength of crossover trials is their capacity to explore personalized nutrition insights. Individual responses to pistachio consumption may vary depending on baseline microbiome composition, insulin sensitivity, and other metabolic traits. By analyzing within-person differences, researchers can identify responders and non-responders, uncovering patterns that inform tailored dietary strategies. For example, participants with lower baseline abundance of SCFA-producing bacteria may experience particularly pronounced increases in microbial diversity and metabolic improvements when consuming pistachios, suggesting that whole foods can be targeted to specific microbial and metabolic profiles for maximal benefit. Beyond methodological rigor, randomized crossover trials demonstrate the broader principle that whole foods exert multifaceted effects that go far beyond simple calorie counts or macronutrient content. Pistachios provide fiber, healthy fats, polyphenol, and plant protein, all of which interact synergistically with gut microbes to enhance SCFA production, regulate glucose, reduce inflammation, and improve satiety. Crossover studies capture these integrated effects, highlighting how a single whole food can simultaneously modulate metabolic, microbial, and systemic outcomes in ways that processed or refined foods cannot. They reveal the functional complexity of whole foods and their potential to support long-term health through both direct nutritional value and microbiome-mediated pathways. Moreover, crossover trials can illuminate subtle yet clinically meaningful changes that inform public health and dietary recommendations. While conventional studies might only detect large differences in fasting glucose or lipid levels, crossover designs can identify improvements in postprandial glucose variability, insulin dynamics, and gut microbial activity, factors increasingly recognized as critical to preventing metabolic syndrome, diabetes, and cardiovascular disease. In the context of pistachios, this means that even a moderate daily intake can produce measurable benefits in both metabolic markers and microbiome composition, providing actionable evidence for individuals seeking practical, sustainable ways to enhance their health. In summary, randomized crossover trials are uniquely suited to uncover the true power of whole foods because they control for interindividual variability, capture within-person responses, and reveal subtle, time-dependent, and microbiome-mediated effects that parallel-arm studies often miss. Using pistachios as a model, these trials have shown that whole foods can improve gut microbial diversity, increase SCFA production, stabilize glucose and insulin responses, reduce inflammation, and support satiety, all while being integrated into realistic dietary patterns. By providing high-resolution insights into both host and microbial responses, crossover designs highlight the remarkable potential of nutrient-dense, plant-based foods to optimize metabolic and systemic health, demonstrating that careful, evidence-based evaluation can transform our understanding of diet from mere calorie counting to functional, microbiome-informed nutrition.